Our planet is enveloped in a magnetic field, an invisible force that safeguards us from the constant bombardment of cosmic radiation. This magnetic field is a vital component of Earth's ability to sustain life, acting as a protective barrier against the harsh environment of space. This shield, generated deep within Earth's core, deflects charged particles streaming from the sun and deep space. The core, composed of molten iron and nickel, creates electric currents that produce the magnetic field. These currents are in constant motion, driven by the rotation of the Earth and the heat from the core itself. These particles, known as solar wind, would otherwise strip away our atmosphere and expose life on Earth to harmful radiation. The solar wind is a stream of charged particles released from the upper atmosphere of the sun, known as the corona. Without our magnetic field, these particles would erode the ozone layer that protects us from the sun's ultraviolet radiation. Just like a shield protects a warrior, our magnetic field is crucial for life as we know it. It not only deflects harmful particles but also traps some of them in the Van Allen radiation belts, preventing them from reaching the surface. This protective mechanism has allowed life to flourish on our planet for billions of years. This magnetic field isn't static, it is a dynamic entity, constantly changing in strength and orientation. The fluid nature of the Earth's outer core means that the magnetic field is always in flux, influenced by the movements of molten metals within. It's dynamic, constantly changing in strength and orientation. These variations can affect everything from animal migration patterns to the operation of satellites and other technology. Scientists continuously monitor these changes to better understand the underlying processes and to predict future shifts. The magnetic poles where the magnetic field lines converge are not fixed either. They wander over time due to changes in the flow of molten iron within the Earth's outer core. This movement is known as geomagnetic secular variation. They wander, and every few 100,000 years or so, they flip entirely in a phenomenon known as a geomagnetic reversal. During these reversals, the magnetic field weakens and multiple poles can emerge. This process can take thousands of years to complete, and while it may seem chaotic, it is a natural part of Earth's geological history. Imagine a compass needle faithfully pointing north. Now imagine that same needle swinging around to point south. That's essentially what happens during a geomagnetic reversal. The magnetic north and south poles swap places. It's a slow process, unfolding over thousands of years, not a sudden, catastrophic event. During this transition, the magnetic field weakens, becomes more complex, and might even exhibit multiple poles for a while. The field doesn't disappear entirely, but its protective capabilities diminish, potentially exposing Earth to higher levels of cosmic radiation. Earth's magnetic field has flipped many times throughout its long history. These geomagnetic reversals are fascinating events that have intrigued scientists for decades. We know this from studying the magnetic signatures preserved in ancient rocks. These rocks act like time capsules, holding clues to the Earth's magnetic past. When molten lava solidifies, iron-rich minerals within it align themselves with the prevailing magnetic field, like tiny compass needles frozen in time. This alignment is crucial for understanding the history of geomagnetic reversals. By analyzing these ancient records, scientists have discovered that geomagnetic reversals are a natural part of Earth's life cycle. They provide a window into the dynamic processes happening deep within our planet. They've occurred at irregular intervals, averaging about every 200,000 years. However, the timing of these reversals is not predictable, adding to the mystery. The last full reversal, known as the Brunhes-Matuyama reversal, happened approximately 780,000 years ago. This event marked a significant shift in Earth's magnetic history. Understanding these reversals helps scientists learn more about the Earth's core and the forces that drive our planet's magnetic field. It's a complex dance of molten iron and nickel, constantly in motion. Ongoing research continues to uncover new insights, revealing the intricate details of how and why these reversals occur. Each discovery brings us closer to understanding the inner workings of our planet. The study of geomagnetic reversals not only helps us understand Earth's past but also prepares us for future changes. It's a reminder of the ever-changing nature of our planet. Section 4. The potential impacts, a mixed bag. The potential effects of a geomagnetic reversal are a subject of ongoing scientific investigation. Some scientists believe that a weakened magnetic field could lead to increased radiation exposure at Earth's surface, potentially disrupting satellites, communication systems, and power grids. Others theorize that changes in the magnetic field could influence animal migration patterns, as many species rely on Earth's magnetic field for navigation. However, it's important to note that these are potential scenarios, and the severity of these effects remains uncertain. Section 5. Debunking the myths, separating fact from fiction. Geomagnetic reversals are often shrouded in myths and misconceptions. Some believe that they trigger catastrophic events like earthquakes, volcanic eruptions, or even mass extinctions. However, there's no scientific evidence to support these claims. Reversals are gradual processes, unfolding over millennia. Life on Earth has weathered numerous reversals in the past, and while there might be some ecological disruptions, it's unlikely to be catastrophic. Section 6. The timescale of change, a gradual transformation. It's crucial to remember that geomagnetic reversals are not instantaneous events. They unfold over thousands of years, giving life on Earth ample time to adapt to the changing magnetic environment. In fact, Earth's magnetic field is currently weakening, but this alone doesn't necessarily signal an imminent reversal. It's like the gradual dimming of a light bulb, rather than a sudden blackout. The process is slow, and we're still in the early stages of understanding its potential implications. Section 7. Staying ahead of the curve. The importance of continued research. While a geomagnetic reversal is a natural phenomenon, its precise timing and potential consequences remain uncertain. This uncertainty drives the need for continued research and monitoring. Scientists are dedicated to understanding the complexities of Earth's magnetic field, which involves studying both current data and historical records. By examining sediment cores and other geological evidence, researchers can piece together the history of past magnetic reversals. Scientists are continuously monitoring Earth's magnetic field, studying past reversals, and collecting data from various sources. This ongoing research is crucial for developing accurate models that can predict future changes. The data collected from these studies not only helps in understanding the magnetic field, but also in preparing for any potential impacts on technology and life on Earth, and developing models to better predict future events and their potential impacts. These models are essential tools for scientists, allowing them to simulate different scenarios and understand the possible outcomes of a geomagnetic reversal. By refining these models, researchers can provide more accurate forecasts and help society prepare for any changes that might occur. By staying informed about ongoing research and supporting scientific endeavors, we can better prepare for the challenges and opportunities that a changing magnetic environment might bring. Public awareness and support for scientific research are vital for ensuring that scientists have the resources they need to continue their work. We can better prepare for the challenges and opportunities that a changing magnetic environment might bring. The collaboration between scientists, engineers, and policymakers is crucial for developing strategies to mitigate any negative impacts and capitalize on potential benefits. The more we understand about our planet's dynamic systems, the better equipped we'll be to navigate the future. This understanding comes from a commitment to ongoing research and a willingness to invest in scientific exploration. The better equipped we'll be to navigate the future. Continued research not only helps us prepare for potential challenges, but also opens up new opportunities for innovation and discovery. By supporting scientific endeavors, we contribute to a better, more informed future for all.